Okay, let's dive in. Picture Europe, but split right down the middle. For June 15th and 16th, 2025, the models are painting this really stark picture, a dramatic split across the whole continent.
It's quite something.
Yeah, so you've got the West and center dealing with this exceptional, really early season heat wave building up.
Baking, basically.
Right. And then over in the East, there's this looming threat of significant severe thunderstorms.
A completely different story.
Exactly. So our mission here is to cut through the sources covering this, understand what's actually driving this unusual pattern, and really unpack what it means for you.
And the fascinating thing really is that these two, well, completely different events aren't separate issues.
Oh, interesting.
No, they're both being orchestrated by one single massive atmospheric feature. It's a persistent, powerful, omega-blocking high-pressure system just parked right over Central Europe.
An omega block, okay?
Yeah, if you look at the jet stream, it literally looks like the Greek letter omega. You get this big ridge bulging north with troughs dipping down on either side.
Right.
And this block, it acts like a huge wall in the atmosphere. Air has to go around it. So west of the block, air sinks, gets compressed, trapped. That's your heat dome.
Got it.
East of the block, you've got cold air being dragged south on one flank, clashing with warm, moist air pulled north on the other. Boom. Instability.
So it's all connected.
Absolutely. That interconnectedness is what makes this whole pattern so impactful.
Okay, so let's unpack that heat wave first.
Uh-oh.
The sources seem pretty clear on this one.
AR.
The most intense heat, it looks like, is forecast for the Iberian Peninsula, Spain, Portugal.
Yeah, that's the bullseye.
And we're talking potential highs, possibly getting over plus 40 Celsius, maybe even locally up to plus 42.
That's the forecast. Brutally hot, especially for mid-June. Really dangerous heat.
And it's not just Iberia, right?
Right.
France, Italy, Germany, the Benelux countries. They're also looking at significant heat.
Definitely. Forecasts show temperatures maybe 8 to 12 degrees Celsius above normal across a wide area there.
Wow. So like Paris, average high is what, around 23, 24 degrees?
About 23.6 degrees C, yeah.
And it could hit 32 to 35 degrees C.
That's the potential. It's a huge jump. Really noticeable, uncomfortable heat.
So what's pumping this heat up so much?
Well, there are a few factors working together. One is the classic Spanish plume setup.
Yeah.
Basically, the circulation around the block is drawing intensely hot air directly north from the Sahara.
Okay, that makes sense.
But the underlying conditions, they really amplify it. A lot of Europe is already pretty dry.
Right, low soil moisture.
Exactly. So the sun's energy just bakes the ground, heats the air directly instead of evaporating water. And maybe surprisingly, the sea surface temperatures out in the North Atlantic.
The ocean, how does that play in?
Well, west of the UK and Ireland, the water is running more than 5 degrees Celsius above average in some spots.
5 degrees. That's incredible.
It is. And while that area isn't directly under the heat dome, that exceptionally warm ocean adds sort of a background warmth and extra moisture to the air flowing into the system, which then gets heated even more as it sinks under the block.
And, I mean, this kind of heat, this early, it feels like we have to talk about the climate change connection here.
We absolutely do. Climate Central did a rapid attribution analysis,
Okay.
and their findings indicate that heat this intense, this early in the year, is now at least 5 times more likely because of human-caused climate change.
5 times.
Yeah. And their climate shift index, which measures the climate change's influence, it's forecast to hit level 5 across southern France.
Level 5, that's the highest.
That's the top level. It indicates the strongest link, impacting potentially over 16 million people there. It backs up what scientists like Dr. Zachary Labe often point out. Climate change isn't just making heat waves stronger, it's making dangerous summer heat arrive earlier.
Okay, so while the West is baking, the eastern side of that same omega block is setting the stage for, well, explosive weather.
Correct. This is where the other side of the coin gets really active.
So what's happening there atmospherically?
On that eastern flank of the high pressure, you have this potent upper-level vortex, basically a rotating pool of cold air high up, and it's clashing with that hot, unstable air being pulled northwards at the surface. That contrast, that clash, that's the trigger for severe storms.
And the sources suggest Western Russia is facing the highest risk from this. Level 2, even level 3 warnings mentioned.
That's what ESTOFEX, the European Storm Forecast Experiment, is indicating. Level 2 and 3 are serious business.
So what kind of hazards are we talking about with those levels?
For Western Russia specifically, there's a significant threat of strong tornadoes. Not just brief spin-ups, but potentially damaging tornadoes.
Okay.
Also, very large hail is a major concern, potentially bigger than 5 centimeters in diameter. That can cause huge damage to property, crops.
Absolutely.
And widespread damaging winds are possible, maybe even organizing into a derecho.
A derecho, that's a major wind event.
It is a widespread, long-lasting line of severe thunderstorms with damaging straight-line winds.
And what about Eastern Europe? Ukraine, Poland, Romania, they're also in the line of fire.
Yes, they're definitely facing a significant risk too. Forecasts suggest a level 2 threat across parts of Eastern Europe.
Okay, slightly lower than Russia perhaps, but still serious.
Still very serious. Looking at large hail, severe wind gusts, and also the risk of localized flash flooding from heavy downpours. And an isolated tornado can't be ruled out there either, especially if individual supercell storms manage to form.
What are the key ingredients making it so volatile?
You've got plenty of fuel, high atmospheric instability, we measure that with a key E, convective available potential energy.
Right.
Values are forecast around 1,000 to 1,500 joules per kilogram, maybe locally over 2,000. That's a lot of energy for storms to tap into.
Okay.
Combine that with strong wind shear, that's the change in wind speed and direction with height. We're seeing 15 to 25 meters per second of deep layer shear. That helps storms organize and rotate.
And that rotation, that's the tornado link.
Exactly, especially the low-level shear. When you look at things like forecast photographs, which show the wind profile, they look quite curved in the lower levels over Western Russia, which is particularly concerning for potentially strong tornadoes. It's often called a loaded gun setup.
Loaded gun.
Yeah, you have this warm layer aloft, sort of a cap, holding things down initially. But there's so much instability underneath that if storms manage to break through that cap, they can just explode upwards with incredible force.
So pulling this all together for you listening, it's really striking.
Yeah.
You have this one single dominant weather pattern that omega block,
The one feature.
creating two totally different, really high-impact weather situations across Europe at the exact same time.
It really highlights the scale of these patterns, and the impacts, depending on where you are, could be substantial.
Right. In the West, under the heat, it's serious health risks. Heat stroke, exhaustion, especially for older people, younger kids, those with health conditions, plus strain on power grids, agriculture stress.
And in the East, under the storms, it's direct threats. Lightning, huge hail, those damaging winds, possible tornadoes, power outages, travel chaos are almost certain in the hardest hit areas.
So it really underscores how vital it is to check your official national weather warnings. Use platforms like Meteoalarm to get the latest, most specific local information.
Absolutely crucial. Don't rely on just the general picture.
And let's talk forecast confidence quickly. It sounds like confidence is high that the heat wave happens and the storm corridor exists, generally speaking.
Yes, the overall pattern is quite robust in the models. High confidence there.
But maybe medium confidence on the peak heat intensity? And maybe low to medium for the exact timing and location of the worst storms?
That's fair. Pinpointing exactly where the most intense heat crests, or exactly which town gets hit by the strongest storm cell, that's always harder. Individual storm behavior is inherently less predictable days out, so confidence is lower on those specifics.
Which means everyone in those risk zones needs to stay really weather aware over the next few days. Things could change.
Definitely. It demands close monitoring. And, this whole situation, it raises quite an important question, doesn't it?
What's that?
Just how one single, persistent, really large-scale atmospheric pattern can cause such wildly different and frankly dangerous conditions simultaneously across an entire continent. It really drives home to atmosphere's complexity, its interconnectedness, and how these big global patterns can play out in ways that seem almost counterintuitive sometimes. Understanding that why behind the forecast is just as important as knowing the what.